Welcome back to my YouTube channel. Today's LeetCode DCC question is meeting rooms 3. So what question is saying, you are given an integer n. There are n rooms numbered from 0 to n minus 1. Also, you are given a 2D integer array meetings where meeting I indicates the start time and end time of the meeting. Also, it is saying the time duration is half closed time interval. That means start time is included but end time is not included. And also, all the values of the start time of the meetings are unique. Okay, so what it is saying, we are given rooms in which we have to schedule a meeting. Suppose, and the numbers of the rooms are from starting from 0 to like this. And also, we are given a list of meetings, and we are given the start time, end time of each meeting. That means, suppose, for example, there is given one meeting duration is given like start time at 2, end time at 4. Next meeting is given at start time at 6, end time at 9. And in the time interval, suppose we schedule a meeting at t equal to 7. At t equal to 7, we schedule this meeting 2 to 4. That means we have to schedule it for 2 units of time because the end time is 4, start time is 2, the duration is 2 units. So we will schedule it till t equal to 9. So in this during this period for at one room, we will schedule meeting number 1. Now for the next meeting, since the start time has already passed the current time, we can schedule this meeting straight away at t equal to 9. That's what you half close time interval is saying. That means 9 is not included in meeting number 1. We can start the next meeting at the t equal to 9. So second meeting will run from t equal to 9 to t equal to 12 because the duration of this meeting is 3. And again next meeting can start from t equal to 12. That's what half close time interval is saying. Now we have what we have to do. We have to allocate these meetings into these rooms. We have to allocate all the meetings into these rooms. But we have to follow certain condition 1, condition 2, and condition 3. And at the end, what we have to return? We have to return the room number in which most of the meetings was held. Most of the meetings was held. So what? So let's look the condition one by one. Each meeting will take place in the unused room with the lowest number. Suppose currently we have room number 2, room number 3, room number 4. All these 3 rooms are available. Then for any meeting, we will first give preference to smallest number of room, that is room number 2. That's what first point is saying. So at any point of time, we will always give preference to the smallest number of unused room which has not been used. Second point is saying if there are no available rooms, if no available room, the meeting will be delayed until a room becomes free. And the delayed meeting should have the same duration as the original meeting. So suppose we take this case, the duration of this meeting is 2 and duration of this meeting is 3. Suppose at time equal to 2, we are not left with any available rooms. So once any rooms will be available, the duration of this meeting will not change. That's what second point is saying. It will still be 2 and this meeting duration will still be 3. There will not be any change in the duration even if the meeting is delayed. Point number 3 is saying when a room becomes unused, meetings that have an earlier original start time should be given the room. That means suppose the start time of this meeting is 2 and the start time of this meeting is 6. So when at suppose at t equal to 7, any of the rooms are available. That means both the meetings are ready to be held. Room meeting number 1, meeting number 2, because their start time is less than this 7. That means both the meetings are ready to be held. But we have to schedule that meeting first whose start time is less. That means we have to schedule this meeting first whose start time is 2. That's what point number 3 is saying. That means there are three conditions. We have to always allocate that room which have the lowest number, and any meeting is delayed will not impact the duration of the meeting. Third, second point. And even if more than one meetings are in queue to be held, we will always prioritize that meeting which have the smallest start time. Correct? Now let's take some example and see. Suppose we take this example. Here n equal to 2. That means we have two rooms and four meetings. So let's make. So now, so at a particular time, we always schedule that meeting who have the smallest start time. So in this, start time is 0, start time is 1, start time is 2, start time is 3. It is already in sorted order, so we don't need to do anything. And how many rooms are available at the beginning? At the beginning, suppose this indicates the availability of the room, and this indicates the occupied. Now in the beginning, both the rooms are available, room number 0 and room number 1. So at room number 0, we will we will schedule this meeting number 1, 2, 3, 4. We will schedule this meeting number 1. So meeting number 1 is scheduled when this room will be available for the next time. It will be available at t equal to 10. That means room number 1 will be available at t equal to 10. So room number 0 is occupied. So now we will remove this. Now the next meeting is start time is 1. So we will check which is the available room. So we have only one available room, 1. So we will schedule that meeting to this room number 1. And when it will be available at t equal to 5. Now next meeting start time is 2. So we will check whether we have any available rooms. We don't have any available room, right? So we have to wait until any of the room is free. So we can see like at t equal to 5, this room will be free. So suppose at t equal to 5, this room is freed. Again, room number 1 is available now. So till t equal to 5, we can see both the meetings are ready to be held. Meeting number 3 and meeting number 4. So but according to the condition number 3, we have to schedule that meeting first who have the smallest start time. So out of 3 and 4, 3 have the smallest start time, that is 2. So again, we will schedule this meeting to room number 1. So when it will be available again, so the duration of this meeting is 5, right? 7 minus 2, 5. And we are scheduling this meeting at t equal to 5, then that means it will next be available at t equal to 10. So again, 1 is occupied and it will be available at t equal to 10. Now now we are left with one meeting, that is 3 to 4. That is meeting number 4. So can we assign this meeting? So let's check whether we have any available rooms. So in this we can see we don't have any available rooms. So we have to wait until any of the room is available. But at t equal to 10, we can see both the rooms are available. So room number 0 and 1, both are available, right? So at t equal to 10, both are available. So according to condition number 2, it is saying we have, according to according to condition number 1, it is saying that we always schedule the meeting in the rooms with the lowest number. So we will assign this meeting in room number 1, sorry, room number 0. So at room number 0, we will schedule this meeting and the duration of this meeting is 1. So from t equal to 10, it will be available till t equal to 11. So it is available till t equal to 11. Now we don't have any more meetings. Now all the scheduling is done. So now what we have to return, we have to return the number of room number that held the most meetings. So we can see room number 0 held 2 meetings and room number 1 also held 2 meetings. So both the room held same number of meetings. So in the case of tie, we have to return the room with the lowest number. So the answer of this example will be 0. So we have to return 0. Let's take one more example. Suppose this is one example. And as we have 4 rooms, now we can see that the start time of this meeting is 2, start time of this meeting is 3, this meeting is 7, this meeting is 17 and 18. So already the meetings are in sorted order with respect to start time. So we don't need to sort it again. So, so according to condition number 3, we are supposed to schedule that meeting first. We have the smallest start time. So we don't need to sort them again. So initially we have 1, 0, 1, 2, 3. All the 4 rooms are available. So but at t equal to 0, no meetings are lined up to schedule. But at t equal to 2, we have to schedule a meeting. So at t equal to 2, we will see which room is available. So we can see all the 4 rooms are available, but which room number we have to in which room number we have to schedule, we have to schedule in the smallest room number. So which is the smallest? 0. So at room number 0, we will schedule this meeting and it will be occupied till 2 to 13. That means it will be freed at t equal to 13. So we will mark this meeting as occupied at, and it will be freed at t equal to 13. So this will indicate the availability and this will indicate the occupancy. Now now the next meeting is 3 to 12. So we will see which room at t equal to 3, how many rooms are available. Is there any rooms which are available? So at t equal to 3, no rooms are available. Only 1, 2, 3 rooms are available. So we can schedule this meeting to the smallest room number, that is 1. So at 1, we will schedule this meeting. So at t equal to 3, we will schedule this meeting. And what will be the duration of this meeting? It's 9. So when it will be next available, it will be next available at t equal to 12. So room number 1 will be occupied till t equal to 12. Now the next meeting is 7 to 10. So by 7, at t equal to 7, how many rooms are available with us? We can see that room number 0 will be available at t equal to 13 and room number 1 will be available at t equal to 12. That means by t equal to 7, only 2 rooms are available, 2 and 3. So at t equal to 7, we will assign this meeting at schedule this meeting at room number 2 because it is the smallest among the available rooms. So at t equal to 2, at t equal to 7, we will schedule this meeting in room number 2. And what will be the duration of this meeting is 3. So it will be available next at t equal to 10. Now again for 17 to 19. So till 17, we will see how many rooms are available. So we can see before t equal to 17, all this room number 0, 1, and 2 all are freed up. So again 0, 1, and 2 are available, right? So at t equal to 17, we will schedule this meeting to the rooms. We will see how many rooms are, all the 4 rooms are available. So we will schedule this meeting at the smallest room number. So that is 0, not 3. So we can see we haven't assigned any meeting to room number 3 yet, but still we have to schedule that meeting to room number 0 because the condition says we have always, we need to schedule the meeting in the rooms which are available with the smallest number. So 0. So at t equal to 17, now next it will be available at t equal to 19. So we'll schedule this meeting and it will be available at t equal to 19. Now next meeting is at 18 to 19. So we will check at t equal to 18, are there, how many rooms are available? So we can see this room will not be freed up till t equal to 18. So only rooms which are left with us is 1, 2, and 3. So among 1, 2, and 3, the smallest room number is 1. So we will schedule this meeting 18 to 19 to room number 1. So at t equal to 18, we will schedule this meeting at in room number 1. So room number 1 will be again occupied till t equal to 19. Right? So now we are not left with any more meetings. So we can see, and room number 3 is not scheduled any of the time. So we can see among room number 0, 1, 2, 3. So room number 0 was occupied for 2 meeting, 1 was occupied for 2 meeting, 2 was occupied for 1 meeting, and 3 was never occupied. That means we have to return 0 because in case of a tie, because we can see 0 and 1 are the room numbers which held most of the meetings, and among 0 and 1 we have to return the room number with the smallest number, that is 0. So again the answer of this example will be 0. So now I have to see means how we can code this. So what we are seeing for availability also, we are every time checking the smallest room number. So we want to get the smallest room number among this pool of rooms available. So we always want the smallest room number. So which data structure can help us giving the smallest room number every time? That is priority queue. If you think priority queue, we will, if we implement mean heap, every time we can get the minimum room number which are available from this pool of rooms, right? So for availability, we can easily implement a mean heap, right? And also from the meetings, if we see the meetings, it once we will sort this meeting from the starting time, it is always like we will get the uh, meetings with the smallest start time in the beginning. So we can easily iterate this meeting one by one and we will get the smallest. So we have to sort this meeting to get the smallest time first. And also we can see like we have to release the meeting also. From this occupied table, we can see we always need to release the meeting. So we have to store it somewhere like for room number 0 is occupied till room number 19, till time 19. Room number 1 is also occupied till t equal to 12. So this thing also we have to store and we want to release it once. Suppose at t equal to 1, we will check whether this room will be available. It will be not set t equal to 13. We can find that this room is now ready to be available. Then we have to move this room number from this occupancy table and move it to the availability table. So that thing we have to do. So again, we can store this information. So where we can store this information, we can store, to store this occupancy table also, we can use a priority queue. How? So we can insert a pair of things like the current means the free release time of this room. Suppose the release time of this room is 13 and the room number. So from the priority queue, we can easily see, suppose if we have the priority queue, what is the latest time at which you can give me one available room. So it will say we have the room number 0 and the time at which it will be available is 13. So let's try to code this. Now, first what we said, we have to arrange this meeting in the sort this meeting according to the smallest start time. So we will sort this meeting. So once we have sorted this meeting, we have to create two priority queue, right? Two mean heap to store the occupancy table and to store the availability table. So for availability table, only we need to store the room number, and but for the occupancy table, we have to store both the room number as well as the time at which it will be released. So let's create the, so this will be occupied table. So we will insert a pair of, so this occupied table will store all the tables, all the rooms number which have been occupied. And this will indicate the availability of the room. Now we will iterate the meetings. Before that, we have to say like all the rooms are available, right? So initially all the rooms are available. So we will insert all the rooms in our table. Now in the available data structure, we have pushed all the rooms that will indicate means all the rooms are available. And when we will ask which is the next available room, it will always give us the smallest number, right? Because we have implemented a mean heap. It will always give us the minimum. Now we will check. At every time, we will also check whether we can release any of the tables from the occupied data structure. So we will see if occupied, we will see if occupied is not empty, or if occupied is not empty as well, the top element of the occupied, that means its first element, it will indicate the time at which the room will be available. So we'll check whether it will be available at the current time or not. So before that, we will initialize the start time of the meeting. Start time of the meeting will be 0 and end time of the meeting will be, duration of the meeting is. So we will see at this time, at this start time, are there any rooms which are able to be freed? So we will check if the release time of this rooms is less than equal to start. That means their rooms are available to be freed. So we will free up that rooms. So what we will do, In the available, we will push the rooms. So we will mark all the rooms which are ready to be available as available. So we will pop the elements from the occupied data structure and we'll move it to available data structure. Now, after doing this, we will check if any rooms are ready to be available or not. It may happen like there are no rooms that are ready to be available. So no rooms has been popped from occupied. Neither we have any available rooms from the beginning. So first we will check whether we have any of the available rooms. This will indicate we have any of the available rooms. So we will find which room number it is available. That means avail dot top. So this is the room number which is available. Now we will use this room. So we will pop it from availability. So as it is available, so for what duration it will be occupied, so that we will mark it by dot push and it will be occupied for certain time, right? So we will push it and comma room number is room. So this room will be occupied. If if the room is not available, then what we have to do? So if the room is not available, then we will see from the occupied table at what time the first room will be available. Any of the rooms will be available. So from the occupied table, we will pop the time at which it will be available. So let's next available equal to by dot first. So this will indicate the time at which the next room will be available and the room number will be this room will be available. That means we will have to wait till next available time to make any of the room as available, and occupied again we have to pop that. Suppose at that time we are coming and we have popped this occupied. Now this meeting will be scheduled at in this room number and it will be engaged. So we will push it to occupied table. So till what time it will be occupied? So suppose the next available room and the time at which the room will be available is 9 and the duration of the meeting is 3. So what we have to do? We have to add this duration to the this next available to make this room available, to indicate the time at which then this room will be available. So it is next available plus duration and also the room number. So this will happen if the room is available, and this else condition will handle if the room is not available. So this is done. So now what we have to return? We have to return the number of the room that held most of the meetings. So once we are we scheduling any of the meeting to any of the rooms, So we should mark that room, or we should have kept a counter to indicate how many times the rooms is available, is has been occupied. So let's create one more counter. We will take a vector and it will indicate the frequency, or we can name it as counter anything. Initially, none of the rooms have been used anytime. So we will indicate at 0. So in this case, since we are making this room occupied, we will mark this frequency of room plus plus. And here also we will mark this frequency of room plus plus. So this frequency vector will hold the value which will indicate how many times that room has been occupied. Now at the end, we will find the maximum. Suppose initially the maximum value is 0 and answer to be returned as 0. Suppose initially everything is 0. So from the beginning, so we will check every room and we will check whether that room has been occupied more number of times or not. So if max is less than frequency of any room, then we will change the max and answer of this room will be I, and we can return the answer. So what we are doing here, we will iterate the frequency table one by one and we will see. Suppose we will first check I equal to 0. That means room number, or how many times room number 0 has been occupied. So it will give, so frequency I will give that. And if this is higher than max, then we will mark that answer as I. That means current till I equal to 0, we have seen like 0th room number has occupied more number of times, and we will update this max value. I hope the solution works. Let's try to run the test cases. So we're getting a compilation error. Okay, so we have closed it here. Let me check it. Where long vector. Test pair. Long vector. No, it's fine. Okay, we have not given any name here. Sorry. So let's try to submit the solution. So what we have done, we have sorted the meeting. We have kept the occupied available. We have made all the rooms available. Correct. We have marked the frequency as 0. In the beginning, we have the start time, end time. We have calculated the duration. We are checking if any of the rooms are occupied and ready to be available. So occupied.top.first will be start. and we will make that rooms as available, and we will pop that room, and if it is available, then we will find the available dot top. We will pop that room. In the occupied, we will push the end time, correct, and the room number, and the frequency of that room will be increased, correct. If else, next available room will be at time occupied dot top dot first, and the room number will be occupied dot top dot second. We will pop that, and in the occupied dot push, we will mark as next available plus duration. So let's see where is the error. Think if frequency of I is greater than max, is equal to I. Else return zero. Return answer. Mm, mm. Okay, sorry. So here we have to keep checking. We have to make it while. Seriously, some blunder. Mm, 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 mm. Shit. Now the solution is accepted. Meet you in the next video.